this is how you convert a binary into an equivalent decimal number. But how about we do other way around? When we say 128, how does computer understands that, right? So we are going to take a quick look on that one too, converting other way around. And that's much easier again. Let's say we write a number, 220, right? We're going to write a number, I'll go blue, 220. How do you know what is the equivalent number? Again, draw, you know that is going to take 1 byte for now, right? Right? 220 has to be translated into a binary, and we have to fill this with 0, 1, 0, 1, 0, 1, whatever. How do we do that? Again, start with here, 1, 2, 4, 8, 16, 32, 64, and 128, the last one. It's a multiple of 2, as I said. So 220, if you divide by, can you divide 220 by 128? The answer is yes. So say yes. Then what's the remaining number out of 220? If you remove 128, because I already represented 128, so 220 minus 128 would be 92, right? Because I already gave 128 value here. By writing 1 here, I gave the 128. So the remaining is 92. Now I have to focus on remaining 92. So again, this is 64. So think like you have what we call it? You have a lot of lack of better word, coins, right? So you are dropping 128 coins by writing 1. You are saying, okay, this one will 128 coins. Now remaining you have 92 coins. Then again you have 64. So you can go here 64. So this will be 1. That means you remove 64 again from here. This becomes 8 and this becomes 28. This requires 32 coins. You are not going to put anything here. Now you have 16. So I'm going to put 1 here. That will remove 16. That makes it is 2 and 1, 12. 8. So you have 12 and I'm going to drop 8 coins here. So that means it will be, yes, this will be filled. Remaining is remove 8, 4. So I'm going to put 4 here. don't have anything here. I will put 0 and 0. So you are talking 1, 1, 0, 1, 1, 1, 0, 0. This is the equivalent of 220. Make sense? Pranav? Rahim? Is it clear? Yeah, Shan.
I don't really get this.
Okay, I'll go one more time. Okay, we'll take one more example. So let's see. Earlier we learned how to convert a binary number into decimal, right? By multiplying with the corresponding position value, right? Let's say I am using 2 words just for you to remember it one more time, right? Every digit has either 1, 0, 1, 1, 1, 0, 0, 0, everything. And it has a position value. That part you got it.
Yeah, right? I got that it's 8 and 1. But
exactly.
it's called a bit.
So you take here 1, 2, 3, 1, 2, 4, 8, 16, 32, 64, and 128. These are the position values. And all you do is to multiply this, to multiply here. And then finally do the sum. That is how you convert. Now we are doing the reverse operations. We are taking a number and we are converting that into a binary value. Okay. And I'll take one more example. Let's say I'm taking this time, give me a number, 127. Right? So I'm taking this time 127. We need to put this in such a way that you have again block, and this time you have to generate the equivalent binary value. 1, 2, 3, 4, 5, 6, and 7. Right? You have to either write 0, 1 in each block, 0 and 1 in such a way that you generate an equivalent of 127. We'll do the same thing here. 1, 2, 4, 6, 8, 16, 32, 64, and 128. Right? And now you start. This requires 128 coins, and you have 127. So you're not going to put anything. So that's a 0. Now 64. Yes, we can drop some here. So I'll say 1 and then remove 64 from 127, which is 3, and it's 63. So I can put 1 here because it can take 32. Then 63 minus 32 is 1 and 31. Right? So I can put 1 here, and that becomes, remove 16, becomes 15. Here, it requires 8. Now I have 15 coins. So I can drop 1 coin here, 1 of 8. And then you are left with 15 minus 8, which is 7. 6 can take 1. So I'll put 1 here. Then you are left with 1. But now you have only 1 coin, and this requires 4 coins. So you're not going to put anything. This is 2. You're not going to put anything. But finally, you'll put 1 here. So the binary equivalent of 127 is 011111001. Made sense?
Yeah.
Okay, cool. So now you know how to convert the the number into a binary also. A couple of facts and a couple of interesting things. When you convert this, you will come up with some interesting numbers. All the odd numbers will end with binary equivalent of, the last one will always be 1, 2, 3, 4, 5, 6, 7, and 8, right? This first house or 0th house, what we call it, right? Numbering starts with 0 in computer. The first one is always be 1 when it is an odd number. And we can try that. You see the number 127, we wrote it here. You see, it was 1 at the end. If you go back, the number we took it here, it was 220. If you notice in 220, this last digit was 0. So looking at the binary value, if the last value is 0, it definitely end up in even number. If it is an last value is 1, it will be an odd number. Why? Because everything else, if you notice, it is a multiplication of 2, 2, 4, 6, 8, 16, 32, 64, 128. So this will result either in even, it will always result in an even number. At the end, you're going to add 1, make it odd. So odd numbers will always have 1 at the end. And if the last one is 0, it has to be an even number because everything else is going to be even. So all the 7 houses will return you an even number. Last one is what makes ticks between on and off. If it is 1, odd number, because you're adding 1 at the end. Make sense? And think of this as, when you're talking about, can everyone listen, hear me?
I had a question.
Yep, yes, please.
So basically you're saying that if it's an odd number and we're converting and it ends in a 0, then we have to add a 1?
No, that last value will always be 1. If you take an even number or odd number, you can, let's experiment with this very small number this time, one quick round, right? So we'll see, let's say number 15. If you put number 15 into this decimal, 1, 2, 3, 4, 5, 6, 7. I put one more actually. 1, 2, 3, 4, 5, 6, 7. Yeah, 15, right? So this one is going to be 1. This is 2. This is 4. This is 8, 16, 32, 64, and 128. So notice I have to distribute 15. This is going to be 0 because I don't have 128. This is still 15. This is 16, and I have only 15. So this also be 0. Now if you see 8. So if I drop 8 here, this is 1 because I can drop 8 out of 15, right? And left over will be minus 8 will be 7. So it requires 4 here. So I can drop 4 here. So remove 4, minus 3, 2. If you put it here, 1 minus 2 equal to 1. Last one goes 1. You see 15 end up with 1 at the end.